Hello, guys. First of all, I want to say that I'm very happy to start a new year on this PPCR. I want that all of you are safe, and I wish you all the best for this new year. Hopefully, and for sure, it will be better than last one. And also that all the things that we could not accomplish in 2020, we get it for this new year. Okay, so let's start the video, and I hope you like it.
So let's start. My name is Gabriel Rangel Olvera. I'm a senior teacher assistant from last year, and I'm a clinical fellow of minimal invasive surgery and gastrointestinal endoscopy at the Dr. Manuel Gea Gonzalez General Hospital at Mexico City. I selected to talk about the research question because, from my point of view, it is the most important part of a good clinical research. With this video, I will try to define what is the research question, describe the importance of a good research question, describe the steps and recommendations to develop a good research question, and define the differences between primary and secondary question. Also, at the end, analyze some examples of good and bad RQs. So, what is the definition of the research question? A research question is a questioning of a scientific problem that was not answered yet. Research and studies try to answer it, creating advances on each field. The objective of the research question is to answer to a specific gap or unknown knowledge. It could be big or small and create new gaps, new research question. Getting useful findings and results. It doesn't matter if they are negative or positive. And also, it will determine the rest of the steps of the study: design, population, outcome, sample size, and all the statistical analysis. On our way to learn about a topic, the wall, we could find some bad or good information or data, the blocks. The gap is the missing data, the missing block, the missing brick. It could be, as I mentioned before, big or small, and we use the research question to find that missing information or data. The better the research question we get, the better brick we will get. So, why is the research question so important? It is important because there is about 90% of failed trials. Chen et al. Mentioned that only 29% of trials were published in journals, and only 13 reported on clinicaltrials.gov. One of the main reasons is poor research question, lack of powerful data, or building the wall on pure quality information or data. A good research question needs to be clear, providing specific information to the audience so that they easily understand its purpose without needing any extra explanation, focused, narrow enough that it can be answered through a specific period of time and tasks, concise, expressed in the fewest words possible, also the complex, uh, requiring synthesis and analysis of ideas and sources prior to a composition of a possible answer, not only yes or no, and arguable so that the possible answers uh, create a potential debate rather than accepted facts. So, what to do? Good research questions require time to determine what is known and to develop it. For instance, we have to ask us what is the best study design for a given question, and given the specific question, which study design leads to the highest level of evidence. We also have to guess and think the possible results and scenarios. Are they interesting? Would they bring new knowledge to my field? After that, we have to test our research question with the experts of the field. It is a feasible idea. Isn't it too risky or ambitious to solve this research question? Some recommendations have been created to guide us during this journey. One of them is to use the Finney criteria. So, what are the Finney criteria components? It is an acronym that means F for feasible, meaning that if it's necessary, we have to adequate the number of subjects for the reaching of our institution, for instance. Uh, Also, if we are designing surgical research, we have to adequate the technical expertise for the surgeons. For example, we won't do a laparoscopic Whipple trial in a general hospital on a small city. Also, if it is affordable in time and money and budget. The other part is the eye of interesting, is that we are getting answers that intrigues investigator, peers, and community of our field and further research. Also, if it is novel, if it confirms, refutes, or extends previous findings or knowledge. Obviously, if it has to be ethical, it is a meaning that it is an amenable study that institutional reviews boards will approve and relevant with significant scientific knowledge and clinical and health policy that will um, create further research and further knowledge. If the idea for our research question meets these requirements, we can jump in onto the structure of the research question per se. For this, we have the PICOT acronym that will help us to define exactly our research question. We have the P for our population, I for the intervention or treatment that we are studying, C for control, O for the outcome or results that we are looking for, and T for the time that our study will have, or the period of time that we will analyze our intervention and our control. So we could ask us, do all the trials fill the PICOT components? Not necessarily. It will depend on the research question and the study design. For instance, we could have some observational study that we will only check for P of population. We won't have an intervention or a control. Will only measure an exposure and an outcome and for a certain period of time. Other studies we will have only a population, an intervention, and a control, and an outcome for a undefined period of time. Or we could have other types of study that we don't have a specific control and we are only evaluating an intervention and an outcome on a specific population. So now, knowing what is a research question, we have to establish the difference between primary and secondary questions. The primary question or the main question is the most interesting one and the most important. It has to be feasible and concrete, as I mentioned before. We are not going on a fishing expedition. It determines the sample size and also its results can be generalized. On the other hand, the secondary questions are exploratory. They are hypothesis generating questions. They qualify the primary question and data from the primary question might answer this type of questions. The problem is that they are not adequately powered because they generate multiple comparisons, increasing the chance of false positive or type 1 errors. To clarify these differences, we designed a study to answer one question. In example 1, is survival higher with the use of remdesivir than placebo on SARS-CoV-2 infected patient? And in the other example, example 2, is survival higher on the robotic Whipple than the laparoscopic Whipple? However, with the same design, the study might also answer other questions. For example 1, we could have the next questions. Is remdesivir associated with more adverse effects than placebo? Is age associated with a good response to remdesivir? Does remdesivir responders have different characteristics than non-responders? And also on example 2, the surgical one, does the robotic Whipple have higher incidence of pancreatic fistula than the laparoscopic Whipple? Do the robotic Whipple have higher operating time than the laparoscopic Whipple? And finally, does the robotic Whipple increase the negative oncological margins compared to the laparoscopic Whipple? With these examples, I try to show you that with only one question we can do more secondary questions that could be answered with the same information from the first one, however, that would need some confirmation and further analysis. So, what to do then? We have to plan ahead of time. All questions have to be a priori specified. Only one primary question should be defined with the fundamental points, and all other questions have to be considered as secondary ones. We have also to limit the number of them and carefully select them and clearly define them. Some other important points, as has been mentioned, is that all these questions will require secondary analysis. So, if we get significant results, new confirmatory studies should be performed to confirm them. Finally, some examples. Here we have the first question, that is, what is the effect on the morbidity from the use of laparoscopic versus open Whipple? And another one that mentioned what is the difference on the incidence of pancreatic fistula and bile leakage between the laparoscopic versus open Whipple? On these examples, we have that the first one is very general and unspecific. Talking about morbidity, we could be analyzing a variety of entities like pancreatic fistula, bile leakage, surgical site infection, postoperative hernias, just to mention ones. So with the second question, we clarify that we will talk about only pancreatic and bile leakage, being the most important complication of this type of surgeries. On this other example, the first question mentioned what effect does surgical simulation with biological model has on surgeon's ability? And the second one is what effect does surgical simulation with biological model has on surgical time and efficiency of movements during the laparoscopic colorectal resection performed by experienced versus young colorectal surgeons? It is obvious that on the second question we specify more the type of population that the intervention, the simulation, will be applied and how it will be evaluated by the efficiency of movements during a specific surgery. Before I say goodbye, I hope you find this video useful. Also, I want to say and repeat that I wish you the best on this new year. Please stay safe, and I hoping for a lot of feedback and comments on this video. Here I show you the image when I went to Boston on 2014 when I was just a student, and also this is the image of my hospital where I'm doing my fellowship now on minimal invasive surgery and on March on gastrointestinal surgery. It is the front part of the hospital. As you can see, it has a kind of coral reef that traps some particles of the polluted area, and also it is one of the main hospitals in Mexico City and one of the principal hospitals to study minimal invasive surgery or gastrointestinal endoscopy. So, with nothing more to say just for now, goodbye. Here is my email, personal, and the one from PPCR. Feel free to contact me, and bye bye.